My name is Mitch Van Ochten. I'm with ROHM Semiconductor, an applications engineer located in Novi, Michigan. Today I would like to talk about some features of two ROHM products. What we have here is a double pulse test fixture, which includes ROHM's third generation silicon carbide product. The transistors we're going to test are the SCT3030, which is rated for 1200 volts, 30 milliohms on resistance. We also have the ROHM Gate Driver BM60052 driving those transistors. We have a KEPCO supply which is set for 800 volts DC, bulk storage capacitors in the back that are going to supply a peak current pulse of 80 amps during the double pulse test. When I press the trigger button on the generator, the pulse will be energized and we'll see the resultant waveform on the scope. Now we can observe the double pulse test. At the beginning of the test, you can see the DC bus voltage from source to drain on the lower transistor, 200 volts per division, 0 in the center. So we're at 2, 4, 6, 800 volts. Transistor comes on. The inductor immediately begins ramping up at 20 amps per division. 20, 40, 60 amps. We then shut off the transistor. The current from the inductor circulates in the upper device. We turn on the lower transistor again. The current continues on its way up until we hit a peak of 80 amps. We then shut off the lower transistor. You'll notice that the current spike, when it was turned back on at 60 amps, the current spike is only about 10 amps. With traditional silicon, traditional FRED diodes, for example, the current spike would be several times higher than that. It's one of the great benefits of the silicon carbide is the way the upper diode behaves when we turn on the part again. I'd like to thank you this afternoon for watching the presentation. On behalf of ROHM, thank you very much.